on Twitch and on YouTube. All right, so I see it. Restream is telling me it's connecting. This is seriously taxing on the old Honey I Falls Time Warner cable system, I think, to be managing 2 internet calls. All right, it tells me YouTube events is online. Now, last time I did this, it didn't pop up. Let's see. All right, so on YouTube, I see iPhone 7 home button. Let's reverse engineer this. Seems to be working. So I see some chat over there. So
I can see it.
YouTube is working, and then Twitch, it says, is connecting. And let's see, Twitch is connecting. We'll assume that it's gonna start working. Let's see.
Looks like.
I think so. Maybe video preview. I think Twitch sometimes has a delay. Twitch says it's got 5 people, 5 Twitch viewers. 5 people are watching us on Twitch. So that's great. All right. So here's it says they're both online. So I am going to click back to Open Broadcaster so that I can see a little bit. All right. So here's the deal. Here's what we're trying to do today. So we've got my iPhone 7 that some of you guys saw me messing around with. So let's talk about this overall problem, and we're gonna mess around with it and do some mad scientist experimenting, and we're gonna connect with Ben Duffy from Geelong Microsoldering. Is that what it is? Is that saying it right?
Yeah.
Is that right?
Yeah, no, you're saying it right. That's right.
All right. And so he's in Australia, and Ben has been got a little obsessed over the last couple of days while I was sick, and I haven't done anything on this, and Ben went crazy. So he's done all sorts of measuring, sniffing lines and stuff that he's going to tell us about for iPhone 7 home button. And then we have Larry Johnson from Handheld Rehab, and that's in Tennessee, right? Or are you over the line?
I'm in Tennessee.
I'm in Tennessee. Larry, you're
Tennessee, because you can hear it in the accent. So you've got 3 different accents going on now.
Yes. This is a melting pot. Yes, we got that. Yeah. Which is what I love about the repair community. It's just such a global repair family. It is. So, hey, guess what, Ben? I saw Larry. I gave him a hug, even in person.
Oh,
yeah. So look at that.
It was pretty cool meeting you, Jess. I mean, we've talked for a long time, and it's actually good. This is the first time I've ever seen Ben. Wait,
now is the first time you laid eyes on Ben Duffy?
This is, I actually pictured him with black hair for some reason. I don't know why.
I like to hide behind the scenes, so heard but not seen.
Yeah.
Right.
Well, yeah. That's crazy. That is really funny. Where there's you kind of talk to somebody every day. Well, when they have an avatar that just says "fuck you" or whatever, what does it say? for years, it said.
I think for years I had a black thing that said, "I don't care, thanks."
Oh yeah, that's what it said.
Yeah.
I don't care, thanks. Yeah, exactly.
Pretty much, "fuck you" is what he said.
Pretty much, fuck you. Exactly. Yes. But these guys are top notch, and they have fantastic minds for this stuff, and so I'm excited to kind of do this idea that I'd like to do more often on this channel. That's sort of like a master's think tank on some sort of a problem. So here's the problem that we're probably not going to be able to solve, but we'll give it a shot. The problem is
cross that.
yeah, we'll cross our fingers. The problem is the iPhone 7 home button is the first iPhone ever that doesn't have the standard clicky style home button. So every other home button in every other iPhone is a really simple on-off switch where you're physically pressing a mechanical switch, and that's what sends the information, which is either just a voltage or a 0. So a 1 or a 0 goes up the line, and that's what the home button signal is. Now, in the 5S, 6, those guys, there was the addition of this fingerprint sensor chip. And let's give that thing a name so that we can talk about it. His name, the secret fingerprint sensor chip that nobody can change. You know, that Apple has all of its proprietary calibration about. His name is Mesa. So the Mesa chip is the secret fingerprint sensor that's actually in the home button. And you can watch my Error 53 video from way back in those days where I tore one up to see, like, could we change it or probe it or solder into it? And the answer was pretty much no. It is a wire bonded chip that is deep into the home button itself. So that's all well and good for every other iPhone. The fingerprint sensor chip was native to the button, but the home button function, the little clicky part, was a separate entire function. So you could piss on the fingerprint sensor Mesa chip and your home button would still work. And that is not true anymore with the iPhone 7. So now the iPhone 7 home button function is no longer a button, and it is functionally tied together with the Mesa fingerprint chip. Even though they're still separate, they're together functionally so that the device will only listen to the home button information if the fingerprint sensor is paired to the device. So here's how that makes a deal. Here's why we care about that. You know, who gives a shit? Here's why we care about this. Because if you take an iPhone 7, what is that? Hey, I can see you. I can see Larry for a split second. There he is.
Yeah. Hey, Larry.
Hey, Larry. he's dressed. This is great. So here's why this is a big deal. If you take an iPhone 7 in for a screen swap, and that's just got a standard cracked glass, and let's say that the technician accidentally damages the home button, that shouldn't be a big deal because they should be able to just reach into the drawer and, in addition to getting a new glass, get a new home button, put it all back together, and you're out the door. But because the home button function is tied to the native button and the fingerprint sensor, you cannot replace the iPhone 7 home button and have the home button still work. Now, that was always true for fingerprint sensor, but nobody cares about fingerprint sensor. But now, if you replace the button, you're going to lose both fingerprint sensor and home button function. You're going to have no home button function if you change that button. If you break it, crack it, damage it, piss on it, tear the flex, anything like that, you will not have home button function on your iPhone 7. That's a big deal. That's a problem. And it's even more of a problem because it kind of sets the stage for a bigger problem, which is what happens when we look forward to iPhone 8 and iPhone 9 if they do the same thing where the home button becomes part of the glass. That means that if you just change the glass, you would no longer have home button function, which really would be the end of screen repair. That's why this is a big deal. So what we're trying to do is to figure out what's going on, how does this thing work at kind of the molecular level, and then the point is to try to think, is there anything we can do about that? Is there any way that we could functionally separate the home button function from the fingerprint sensor so that we could restore home button function and just give up on fingerprint sensor, essentially returning the iPhone 7 situation back to the same way iPhone 6S, 6, and all those other guys work. All right, so let's look at chat for a second, and then we're going to have Ben take over, and he's going to walk us through what he has found out about iPhone 7 home button function from the schematic. But let's look at the chat here for a second. So one thing I want to do is see if my little app that lets you, where is there a little app that lets you see both chats? I don't know what happened to that. Is it this? Let's see. Does that work? Chat. Oh, yeah, I can see some chats. All right, so let's scroll back up. And you guys, Ben and Larry, can see this on either Twitch or YouTube. A lot of pings and tests and highs. Let's see. Twitch chat cuts out. Is Jessa gonna stream? I hope so. Wait, guess in 1 hour looking at the Twitter post. What? Scheduled streaming? I don't know where that's coming from. Let's see. It's working. Hi, Lewis. I mean, Jessa. Is this live chat real? Yes. YouTube is working. Whoa. Twerk for 5, is that euros? Sure, I'm sure Larry has got a mean twerk that he'd love to do. I have an iPhone 7 with a bad button that I messed up fixing the screen. All right, well, let's hear more about that. All right, Merry Easter. Why is the cam from Australia not upside down? My worldview is destroyed now. Yes, that is something. It's upside down for me. I don't know what you're talking about. Let's see. Repair family. Do we have a Twitch on this one? Yes, I think so. I see some Twitch comments that are mixed into this stream, which is good. Nice to be back again. Drinking whiskey in Tennessee. A bunch of hi Jessas. So I was already here. I must have just missed the transition to it being active here. Okay. Hi everybody. Lewis is now hosting your Twitch channel. Well, that's great, because I was hosting his Twitch channel with my, like, 4 people that watch Twits. All right. Break it, damage it, piss on it. What if I do all the above? Okay. Let's see. Doing this again. You found the golden ticket. We don't know. Ben's got a hot lead. That's what we're going to find out about.
Maybe, yeah.
It creeps the shit out of my autism that Jessa looks directly into. It's not into the camera, it's into your soul. I'm doing it right now. All right. Let's see. Don't read what I did right up there. Whoops, sorry about that. You have to look at solving it in an engineer way, not in a technician way. Reverse engineering is on the right track, if possible. Well, we'll see. I mean, we have some limited tools here. We're going to do our best. She's going to read everything. No, I'm not. I'm going to read what makes sense. Okay, practically text to speech. Wait, which one is the Aussie? Well, see if you can figure that one out. If you can, sitting in Australia, if you cannot, Paul, figure out which one of these guys is from Tennessee, then that's like a challenge. All right, you're Lewis's son, right? Yeah, that's which one of you guys is Lewis's son? That's pretty funny. Okay, all right. Let's see. Anything else? Logic analyzer or oscilloscope? Well, I really wish I hadn't sent my oscilloscope with Jason from Motherboard Vice. I need to get that back. But we don't have we've got some tools though. Okay, so we are ready to go here. So I'm gonna just move that thing out of the way, and I'm gonna close that, and we're gonna go back here. Okay, so Ben, what can you tell us from the schematic about your research with the iPhone 7 home button? Let me see if I actually have that one. For anybody that missed our earlier video, I tore one open just to dissect it, and it was seriously trashed. I'm not even sure I have the carcass anymore. But here it is. All right, let's look. Let's just take a look real quick, and then we'll have Ben take over here on the schematic. Well, let's look under the microscope at this. So we are going to go to Microscope. Oh, let's not do that microscope. Let's do this microscope. And this is what the iPhone 7 home button looks like for anybody that missed that first video. So the deal is that the button, so this is kind of the back side of the button. And if you dig into this and you get rid of the crystal glass on the top, then this guy is the Mesa chip. This is the actual fingerprint sensor chip. And you can see that he's connected to a big flex here, kind of a thick home button flex. Now let's flip this over. And at one time, there was a smaller flex right here that was also feeding into and sitting underneath that Mesa chip. So this is probably a capacitance sensor or several of those that can actually tell how hard or light you're touching the home button on the other side. And then it's going to convey that information through this little flex to the new chip. Now this guy is Turtle. So this is the new chip, and if you look at his ID number, we can call him AD7149. So this guy, Apple, in the schematic, and I'm right, Ben, this is Turtle? This is Turtle, right?
That's Turtle, yeah.
Yes, this is our buddy Turtle. Do you have any idea, like, what about it? You know more about this chip than anybody here. Why the fuck is it called Turtle?
The only thing that I can put it down to is that the communication is ridiculously slow on that compared to everything else in the phone. So I'm thinking that they called it that because of how slow the communication is.
All right, I like that theory. All right, maybe. So here's Turtle. So Turtle's job is to take the capacitance, the information that it's getting from your finger touching the button, and it's going to turn that from capacitance into digital information. And then it's going to send that digital information up through the flex to the connector. So now this is the connector that plugs into the screen. I don't think I have my screen anymore. So this connector plugs into the screen, and it's going to go through a flex then and ultimately plug into the logic board. So this guy's job then is to convey both the digital capacitance information as well as the fingerprint sensor information from the Mesa chip. So this is what it looks like kind of structurally. All right, so that's where we are with that. So now let's look at functionally. So we'll do like anatomy and physiology. So there you go. Anatomy lesson is concluded. We will put that to the side. And Ben is going to tell us about the physiology. So I'm going to go to a screen view here. And I think if you... How were we doing that before? Did you share your screen, Ben?
Yeah, I'm already sharing that.
Okay. All right, so then let's make that bigger. And maybe I wanted to do the window, I think. Let's see. Yeah, let's just do that. Let's just drag this up. Okay. All right, that's good. Okay, can I see your mouse on there?
I don't think
you
can.
Yeah, I can. Yep.
Oh, you can?
Yes.
You can see them now.
Yep.
Cool.
So that's the home button connector on the board?
That is the home button connector on the iPhone 6S. And I just have that up because I wanted to point out that previously we had this menu key line, this button menu key connector L or low, which was previously our home button. So this is what it looked like on every other iPhone prior to the iPhone 7. And then on the iPhone 7 schematics, it is gone. There is no longer any menu key, but there is some new lines. So we've got the I2C turtle data lines and no menu key. So when we sort of started out on this venture of you know, why the home button doesn't work after you change it and how the home button actually works, we sort of started looking at the schematics to find out what was different and where the data for you just press the home button is actually coming from. And it turns out that it's coming from these turtle lines. So we pulled the home button apart and we found out that what was it, the AD7149 IC is where those turtle lines connect to, and that is the same IC that was used in the digitizer of the Apple Watches. So it's not something that's new to Apple. but it's sort of something that's new to the iPhone. And after a
No,
whole
wait.
heap of
So let's
search,
talk about that for a second. In the Apple Watch digitizer, don't
Yeah.
people have a whole lot of trouble with those? Like replacing those now it doesn't work, blah blah. You think that's just mechanical, or do you think it might have something to do with some kind of ID marriage to the CPU?
I wouldn't think so, because the IC itself, so the AD7194 is it's used in a whole heap of different devices. Its main purpose is for interfaces with capacitive buttons on sort of anything. So it could be integrated as a digitizer or as a single home button, or you could have like a touch panel, say on a printer, where you've got touch buttons that correspond to different things. So there doesn't seem to be anything about it specifically that is unique for each device. So I think the unique part of it is with Mesa itself, the secret IC that we know nothing about. So there should be no reason then that if you change the home button flex, why that IC would not be working. And we have since discovered why that is the case.
Okay, why is that the case? Oh, by the way, somebody's asking, who is Jess's guest? This is Ben Duffy, and we also have Larry Johnson. So Ben Duffy is the guy who's smoking a cigarette on the other side of the world right now. He's in Australia, and he's one of the guys that I talk to every day. Very smart guy, and he's been working on this home button project. And then Larry, who we'll get to later because he has another candidate iPhone 7 that we can fuck around with when we get to the lab section of today. So we're doing anatomy and physiology, the home button, and then we're going to do a lab. So then we'll talk more to Larry. All right. Yeah. So what else? So now we know what's going on.
Okay. So we know So I'll just pull up here. So what I did was I got the pin out from the connector itself on the board, and I worked out sort of what lines go to Mesa and what lines are specific to Force Touch. And so I went through and I isolated those.
Did you make these things? What the fuck?
Yeah.
This is what you've been doing? You're like a little white SOM Tesla now.
Yeah.
Look at you.
I mean, this was just me sort of mapping out pins to make it easier for myself, so that I could sort of work out. Because initially we weren't sure that Turtle was the home button. For all we knew, it was sort of related to Force Touch or something. So we weren't 100% sure which lines were going to be for the home button. So this is why I mapped it out. So I started at the board. I then mapped it out on the flex itself, because there's no pin out of the actual home button flex itself. Only its sort of connector on the board. So we mapped that out, and then what I did was that's a strip view of the home button. What I did was this. So I mapped out those pins on the connector itself, and I removed the AD7149. And I found out where those lines actually go, and which ones are sort of relevant to the home button, and what each pin connects to, and what doesn't connect to anything. And so what we found out, which we can see in this sort of strip view of the home button, if I can get rid of that,
so
we found out.
A question: are you planning to publish these pictures anywhere?
Yeah. I'll upload them to some kind of image sharing thing, and give you a link to stick in your description, I guess.
All right, sounds good.
Yeah.
Good work, man. You're like a little grad student over there with your poster at the convention. So last night when I ended up having, did you see my stream last night? Was it nothing but a giant rant on bullshit Doritos?
I saw the last part of the stream.
It was ridiculous.
So
I fixed nothing. So earlier I had tried to convince Ben to do this last night because I'm going on vacation tomorrow and I haven't done any laundry or packing or anything, and it's 10:35 p.m. But I thought this was, I wanted to get to this because I need to take my iPhone 7 back to Apple probably before I get back. So I'm excited that.
Yeah.
So I can see you were busy. All right, I'll give you that. Okay. So continuing on.
Okay. So we know that we've got this new part. Can you see my mouse on there, or?
Yes.
I'm not sure. So we know we've got this new part of the Flex here, which has got these two sections here, and that they feed back into this AD7149 IC. And when I eventually found the schematics of that, I found out that just go here, I guess. I found out that all of these sort of white pins here are potentially capacitive button inputs.
Okay.
And the iPhone 7 home button just uses two of those. So you've got two separate sections of button, which I assume is so that, depending on where you press on the home button, it still registers a home button press.
Yep.
And so we've got those that feed back, and I'll pull up the schematics actually for the AD7147A, which has the same pinout. Let me just go down through here and we'll pull up an application example. It's here somewhere. No, I went too far.
So how'd you figure out that this one is the same as the 4.9?
Yeah, so what I did was I started mapping out we'll go here. I started mapping out where these little pads on the balls correspond to the connectors, or the connector rather. And so I found out that the PP3VO Mesa power rail connects here, and that you've got the 1.8 volt rail connects there, and then our I2C lines, or I2C lines connect to these two lines here.
Wait, people really say I2C instead of I2C?
Totally, yeah.
Really? Wow. So unprofessional. I had no idea.
Yeah. So I knew what some of the pads were.
Okay.
And I couldn't specifically find a data sheet for the 7149, but I sort of went through the 714 series, which is quite a few ICs, and I eventually came across this guy, which is here we go, which is ball grid array, and I found that there's two types of the 7147. So you've got one that has SPI, and one of them that has I2C. And then I looked at the pinout for that and went, oh, well, our ground lines correspond to where the ground line should be, and our VCC corresponds to that 3-volt Mesa line, and then I went by that. So it looks like this is the pinout for that IC, and this is an application example of that IC in circuit. So from that I worked out what the rest of the pins were, and I worked out that most of these pins don't get used because there's only those two capacitive buttons in the iPhone 7 home button, and that is how we came to here. So what we know is that these capacitive buttons here connect back to the home button. We know that it gets its power from the Mesa power rails, which when you connect a non-paired home button are still present. So the phone isn't turning those power rails off. Those power rails are sort of always there. So the IC always has power.
So that was one of our kind of earlier ideas after the first dissection, was trying to think why this would make sense. Why would they be paired? And one idea was that if there's one power line for, let's say, the fingerprint sensor for Mesa, that the device will disable once it realizes that it doesn't have the correct Mesa, that it's got none or a BS or wrong Mesa chip, that it would cut power, and therefore it would make sense to not have the home button. But that's not the case.
That's not the case. So the IC always has power, and so I sort of started looking beyond that, and I went to to the schematics here, and if you have a look, each button connects to its own pin, and then you've got the ground plane on the board, or a shield which is used to reference to those buttons. So
those buttons are capacitance sensors.
Yeah, so each one of those buttons is basically just a pad, and the pad is surrounded or in very close proximity to this AC shield line, which is in a typical application that's a ground plane on a board, and so when you touch one of the capacitive buttons, it would drop the voltage on that line slightly. It would pull that line low, and that's how the IC knows that you're pressing a button.
Okay.
And so if you have a look on the pin out here, that it would make sense then that this little light blue ball here would go to the we've got one here, go to the shield on the back of the home button, so that it can then sort of have its ground reference, its shield reference, to pull those lines low. And I found out that's not the case. This line actually goes back to that secret Mesa IC that we know absolutely nothing about.
Okay, so let's say that again. So what we understand here is that the capacitance sensors, which are the 3 pads. So go back to that picture. Go back a slide. Does that go back? Can I hit that?
Back to here?
Yeah. So these 3 buttons, 1, 2, 3, are the sensors that your finger touches, and those convey a signal into the chip. And those signals are landing at, let's see, 1, 2, 3. So then the chip knows what's up. Dude just pressed me. And then he's got to tell somebody, dude just pressed me hard. Like really hard. He's like pretty pissed. He's beating my ass. I'm going to go tell mom. So the theory is that information is then going to leave the chip and go up and tell the CPU, Mom, some dude's pushing my buttons. And your theory is the output was this guy here. Is that right?
Sorry, my stream's delayed. So.
Oh, I see. So tell me, where's the output?
So the output from the IC are these I2C lines here. So this SCK and SDO.
So 3 outputs. The hey mom, somebody hit me is these 3 lines here, which are I can't see, it's too far away and my eyes are too old. So it's like a data line, a clock line, and then an interrupt.
So there's 2 data lines, and you've got an interrupt line, which can sort of go back to the CPU to tell it to stop whatever it's doing because someone just pressed a button.
Okay.
And in the case of the iPhone 7 home button flex, there is a trace that connects to that. It doesn't actually go anywhere, so it looks like that's just a test point. So the interrupt is sort of not used on the iPhone 7 home button in particular.
Okay, so let's pause. Let's pause here for a second because I can read the chat sort of at the same time here. And one thing was, some guy said, "Great work so far, Ben." But then it sounds like, honestly, chat folks, it sounds like I'm gonna move this to this for a second. It sounds like all of us, like any other problem, just like a customer, you want there to be an easy answer. And, you want for things to turn into please, bro, answers. Like, hey, bro, I got error 56. What is it, bro? What do I need to change? And we want that thinking to work. We want it to be black and white, problem and solution. But it's not like that. It's not like that, and it's especially not like that when you're trying to understand and figure out how things work. So it's if you kind of look at this and say, I see a chip, can I change the chip to another flex? Let's do that. Stop. Let's think about that and think. And here's the deal. I don't know shit about how communication works. I had to look up what the hell bus meant, communication bus. Oh, okay, and you can do that. You can go to Wikipedia. You can go to Google. You can just look around. You can ask people. You can talk to people, and just kind of find out what these things mean. But essentially, here's the nutshell. The way things work. Let's kind of go back to kindergarten a little bit. The way chips work is power and data. So power means a chip is plugged into the wall. So it's got power, just like a lamp. It's plugged into the wall, but it doesn't mean the lamp is on. I can turn the lamp off. This lamp's off, on, but it's plugged in. It's got power the entire time. So a chip has to have power. And for the case of the home button, it looks like the home button function is controlled by this chip called Turtle, and his other name is AD7149. Is that right? 7149? Yep, so AD7149, aka Turtle, is a chip on the flex that controls the home button function. There's another chip, Mesa, and Mesa is the fingerprint sensor chip. Both of these chips control two different things, home button function and fingerprint sensor function, but they both have to have power. They have to be plugged into the wall. So the first thing that Ben told us was he figured out how do they get power. And that was a line on the schematic that was called PP3V0 Mesa power. And does it have another power rail, Ben?
There is. It also uses PP1V8 Mesa.
Okay, and so another one which is PP1V8 Mesa, and sometimes a power rail could be used as a signal, and that may be the case for that second one. But we definitely know that it's plugged into the wall by PP3V0 Mesa, so we know that. So then everything else looks like data. So what is data? Data is ones and zeros. So everything else that the phone does is brain activity. So I want you to think about that when you're troubleshooting phones or troubleshooting any board, that power is like heart and blood flow. A chip has to have a connection to blood flow. But that's not the whole story. Just like a person could be brain dead, but their heart's still working, so can a phone. So you can have, it's not as simple as, my phone won't turn on, replace power IC, bro. And the videos that are out there, dead phone, no power fix, replace PMIC. Those lead you into this thinking that doesn't apply. So let's think more like physicians. This is anatomy and physiology, and then we're going to do a lab. Let's think about physiology here, where we're going to think about it, heart and blood flow and power, but also think about brain, nerves, and neurons that are controlling chips, listening in, telling them to do things. That would be kind of like a switch on the light switch. So switch, on, off. That enable or switching it on is a data line. So if we kind of apply that to this chip or what Ben just told us, what we get is that the home button seems to have to do with this Turtle chip. And the way that it works is that Turtle has a couple of feelers out here, these sensors that sit under the button itself. When your thumb presses the button, you're touching these sensors, and these sensors are then going to touch ground. And you can see how that would make a 1 and a 0. And then that information goes to the chip. The chip's job is to turn that into data through neurons and go tell the brain, the CPU. So the chip is going to be able to sense grades of your touch, and that's the whole point of why it's an improvement over a simple off-on. Now we can tell force, and in sort of now we've got a continuum of how you're touching the button. So the chip's job is to translate that touch into ones and zeros. And so the output of the chip are these 3 data lines that Ben was just telling us about. And so you would think that the data lines are going to go from the chip to the CPU, because that's where it would make sense that they would go. And that's where we left off with Ben. And I'm learning from Ben. He's told me this before. I read it briefly. So I'm following along with you, and I'm listening to Ben. And I think Ben's doing a fucking fantastic job. And if you feel like you're lost or you can't follow, ask a question, because this channel is about teaching you to think and to just have more folks looking at these problems in this way, because we're really sort of counting on a larger effort than just me or just Ben or just Larry or just a small group of individuals. There's anybody can have a great idea at any time and bounce off of each other's ideas and kind of work together. Because if we don't figure out how these things work and understand it, then we're really at a loss. But in this case, what we're going to see in this story is that it looks like there may be a way to intervene. And we're going to find out that it looks like that this design was maybe not created in the simplest way to solve the problem, but it may have instead been created in a way that kind of limits our ability to intervene. And then that itself is an issue that we could take issue with and draw public attention. But we have to understand what's going on. And I want you to give yourself permission to not be an electrical engineer and to be a mom who sits in a dining room that's just a reasonable person that can listen to something and go, is it basically like this? And I think that's going to work. Okay, so let me see. All right, so let's see. All this stuff. Yes, I'm on Twitch and YouTube right now. So Twitch is Jessa_iPad Rehab. Probably hard to find. They probably put people that are over 40 on Twitch like way at the bottom. All right, so let's go back to where we left off here, because I think this is important content. So, all right, so Ben, where we left off here, we were saying that there is the fingerprints or the little sensors here, sensors that your finger touches. And the sensation, the capacitance of your fingers on those sensors gets conveyed to the chip. And then the chip is going to do something about it. It's going to turn that into ones and zeros. And the ones and zeros are going to come out on these 3 data lines. The first of which is an interrupt line. And that interrupt is like somebody running ahead that's just knocking on the door. Pay attention, getting ready to tell you something. So that seems to be the function of this interrupt. Is that true?
Yeah.
Yeah. So the first time I've ever heard the word interrupt in signal and logic was, I don't know, a week ago. But this is not that hard to understand. And then these two guys are paired, right? Or not? Are they kind of paired like clock?
The other two data lines?
Or we don't know?
Sorry, is that the other 2 data lines?
Yes.
Yeah. So they're paired in a way. So one starts before the other one, and it just they both spit out ones and zeros basically.
And so we are expecting that they're going to go talk to the CPU.
Yeah. And
do they?
They do. And in the case of a functional home button, what happens is when you touch that button, and the little AD 7149 turns that into digital data. That digital data can be seen with an oscilloscope or a logic analyzer on those 2 lines. And that was where it sort of got tricky, because I then connected a home button to a device that it was not paired to, and there was no longer data coming out on those lines. And instead what I found was that the lines were stuck low, so they were stuck. They were stuck at 0. They were always low, and you couldn't see any data on them. But the fundamentals of how the chip works, which is that it has power, that it has ground, that the button is connected to it, they were all still there. So then we sort of had to work out why those lines were stuck low, and it turns out that those 2 lines also connect to that secret Mesa IC, which pulls them low.
In addition to the CPU.
Correct. So they're sort of connected in parallel. So the CPU listens on the turtle I2C lines.
Yep.
And Mesa also connects to those lines and is able to pull the lines low to stop communication on those lines.
All right. So let's say that back, because that is really key to our potential ability to intervene here. So what Ben
Yep.
said is that there's the 3 outputs from the home button chip, Turtle. The first one is knocking on the door, hey, pay attention to these lines, important transmission coming through. And then these lines, when Ben had a paired normal native home button, these were full of 1s and 0s. So that was information that was going to the CPU.
Yeah.
However, when Ben plugged in some other random home button that we know isn't going to work, now these lines, instead of being full of 1s and 0s, when everything else was working, now they're just 0. They've been pulled low. They're 0s. So why were they pulled low? What happened? And what he figured out is that they don't just go to the CPU. They go to the other chip, the fingerprint sensor chip. And I'm going to take you back to the microscope for a second. Remember, we have been talking about this home button chip, Turtle, and Turtle's function. But remember, this flex here, here's the flex that goes to the little capacitance buttons in here. It also goes to the main fingerprint sensor chip, which you'd think would be unrelated to home button function. This is the fingerprint Touch ID, Mesa chip.
Yep.
But what Ben's telling us is that the information from the home button that goes into the Turtle chip, Turtle is supposed to be telling the CPU, but it's also connected back to the fingerprint sensor chip, so that when you've got a non-original home button, that message on the data lines of 1s and 0s gets pulled down by the fingerprint sensor chip. All right, so that's what you just said again. So let's continue on then.
Yep. Okay. So I sort of thought about why that would be the case, why there would be a need for that, and that's when I sort of thought, well, when you're scanning fingerprints, you don't always want to go home. So if you're programming a fingerprint and you're pressing on the home button to have it register your fingerprint, you don't necessarily want to go back home. You don't want to exit that programming of fingerprints. So Mesa needs a way to disable the AD7149 to stop it from telling the CPU to go home, because there's instances where you want to just scan the fingerprint and not necessarily go home. So
Paul Daniels has a question. Is it both lines being pulled down or just the SCK?
It is both.
He says it is both.
Yeah. Yeah. So both lines get pulled down. And I think the reason for that is just that when you're pressing on the home button, that IC would be outputting data, it would be spitting data out, but Mesa needs to interrupt that data, and it needs to tell the CPU, or it needs to stop the IC from telling the CPU to go home, because at the moment we're using Apple Pay, or we're programming a fingerprint, or we're doing something that requires the fingerprint sensor to work, but not home.
Okay, makes sense.
Yeah. And so it would stand to reason that if that's the case, and that Mesa is causing those lines to get stuck low, and Mesa is not paired to this particular device, so it's not going to work as a fingerprint anyway, that we could just cut the lines or interrupt the signal between Mesa and the AD7149 and stop Mesa from being able to force those lines low, stop Mesa from being able to pull the lines low. And so I had a home button here that was damaged, and I did that. I cut the lines.
So so what you're saying is that we can't just come and rip these out, because they need to transmit the home button information from Turtle to the CPU. So we can't just come in here and rip them out. Yeah. What we want to do is we want to rip out the connection between these lines and wherever they continue on to Mesa. So we want to just cut the highway. We want to wash a bridge out between Mesa, the fingerprint sensor, and Turtle. But we want Turtle to be able to continue to talk on those same lines to the CPU.
Yeah.
How are we going to do it?
Okay, so I mean, all we need to do really is we need to cut the Mesa, the secret IC that isn't paired and isn't going to work anyway, out of the equation. And so the easiest way to do that is to cut through that thicker flex that goes to that secret IC so that it is no longer connected to the device in any way at all. And also no longer connected to the AD7149. And I did that, and I checked, and the data lines were no longer getting stuck low. So that fixes the problem of, Mesa interfering with the turtle data lines. But then when I pressed the home button, there was still no data coming out. So the lines were no longer stuck low, but there was also no data coming out of the AD7149. And so that is when finding the schematic here and the application example came in handy, because what I then found out was that this AC shield line, so this line that that is for the ground plane that the buttons use as a reference, did not actually go to a ground plane. So it doesn't go to the metal on the back of the home button like you would expect. It also goes into that secret Mesa IC. So by cutting the communication between that secret Mesa IC and everything else, you also cut out that reference that the IC that the AD7149 uses to detect whether or not a button's being pressed. So those button lines then end up floating, and they don't actually go low when you press on the button. So
you're saying that you severed its reference to ground.
Yeah, more or less, yeah.
Okay.
So it solved one problem, but it introduced another. So it solved the problem of lines getting stuck low, but then it introduced the problem of the buttons no longer having a reference, and so when you press on the home button, nothing happens, and no data comes out of the IC. So if you take Mesa out of the equation, it would stand to reason that this little blue ball here, this one for the...
Well,
the
show me
AD
where did you cut on this picture?
We can't see it on this picture. We'll go back to, and if I zoom out, go back to this picture. So we're looking at right here.
Yep. So
Yep.
you just razored right on through that shit.
Pretty much, yep. Yep. So the flex
was it oddly satisfying? What did you do with the button itself? Did you make it into an earring?
No, the button is still attached, because see, when the button's assembled, these two parts are one piece. Yeah. So you've got a severed connection to the secret Mesa IC.
Okay.
But this sort of flex remains and is still attached to the button itself.
Okay.
So we solved one problem, which was the lines getting stuck low.
Yep.
But we got rid of our reference to ground. So I actually fried my AD7149. I connected it to an Arduino without setting the pins as inputs, and I accidentally fed 5 volts into the I2C lines and fried it. So
son of a bitch.
Yeah, so at this point, I thought, well, if we take this ground reference line and we manually connect it directly to the metal for the home button, which we believe is what Mesa does. So Mesa switches the connection between that shield output line, or that ground reference line, and the shield on the home button. I thought if we manually connect it to the metal on the home button, then we have all of our sort of fundamentals of how that IC works back. We've got our ground plane.
Hey, Wyman is watching us. That's awesome. I hope you can understand us, and we can enable subtitles or something. Yeah,
so I didn't actually get a chance to test it, but I thought, what happens if we then reintroduce that line that we've just cut, that shield line, and we give that button a ground reference again? So that is what we are going to do, or that is what you and Larry are going to do.
Yeah.
To find out if it's enough to have the data spit out. And then what the problem is that it raises another question, and that is, so in the beginning we weren't sure what actually stops the home button from working. Was it software, was it hardware, or was it both? And we've confirmed that it is hardware, and that the Mesa IC is interfering with those I2C lines, but we don't know if it's also software. So what we need to do is we need to get this IC spitting out its data again, We need to give it that ground reference, and we need to have it communicating with the CPU again, and then we will find out if that is enough to trigger a home button press, or if the CPU is then going to ignore that data due to software. So this could be a win. We might end up with functional home buttons, or we might end up with nothing, and then we can, well, you can't, but the next step from there would be to check it with a logic analyzer, make sure that the data is coming out, and then we can sort of, you know, go at Apple with the ammunition that we know that there is software at play, you know, ignoring that data.
All right, makes sense. So now we are ready to move on to, so let's kind of make this smaller again and stick this over here. Where could I put this? Let's do that. So let's embiggen you. I don't know if I can do that or not. So let's before we kind of move on to the experimental phase, I want to make sure that everybody's clear with what the plan is and why. So let's check in and see if anybody has any questions. So if you're not following, now's your chance to say, wait a minute, I don't get it. So let's have a couple of you guys in the comments, especially if you're on Twitch where they don't have the character limit, say back to us what the idea is here. What is it that we are about to try and do, and what's the plan? Wyman, I wish I could speak Chinese, but our plan is to try and see if we can separate the Touch ID fingerprint sensor to separate that from home button, menu key, home button. All right, so that's the plan. So Ben Nash is going to send Ben Duffy an iPhone 7 on Tuesday. Ben Nash is also in Australia. We've got a lot of, I don't know, Ben, can you see this chat?
I can.
Okay, good. All right, so we have iPhone 8 still a big worry. Great work, Ben. I have a simple question. What's the name of the form factor of the connector on the flex cable? Forgot that one. No idea what you're talking about. All right, let me scroll back a little bit. Let's see. I'm reading the chat to see if there's anything that we can answer. Somebody's telling me to be quiet. Let's see. Yeah, the open board view Paul is Paul Daniels, who has is PLD 73. All right, so let's see. Okay, I've told Ben that 10 times. Yeah, so we I'm scrolling back. I don't see anything that's really kind of germane to this, all the way back to Paul's comment about whether or not these are both pulled down. So, I mean, we're open to anybody else's ideas. If you kind of heard that and made you think something, then let me know. So I'm going to scroll back here to the beginning. So we've got a guy asking, why do this? And the answer is because what we'd like to be able to do is to ideally make it so that any iPhone 7 that has a problem or a tear or an accident in the home button, that we could change that button out with an aftermarket home button or some other original pull home button. And if we were able to modify it in a way that was very easy and feasible, then we would be able to allow the button to have home button function and therefore be a pretty good phone, and it would just lose fingerprint sensor function, which is the way it already is for iPhone 6s, 6s Plus, 6 Plus, 5s. So those phones all lose fingerprint sensor function if you lose the original home button. It'd be nice if we could just get our hands on the Apple calibration machine where you could get a new home button, program it, and everything would be cool. But that is unlikely to happen. So what we're trying to do is to just research and at least understand how this stuff works and see whether or not there might be a feasible workaround so that if you damage an iPhone 7 home button, that you're not on the hook for getting this guy a new phone, because you really can't have a customer come into you with cracked glass and leave with no home button. Home button's pretty important. Nobody wants to sit there and use assistive touch for a long time. So you're going to be on the hook if you damage a home button in a very serious way with the iPhone 7. All right, let's see. Yep, restore home button if Touch ID fails without having to go to Apple. I think you'll have to hack the I2C protocol. I refuse to say I2C. That's I can't do it. I mean the connector that's used to put the flex cable onto the phone's logic board. It's a flexible flat connector, or a flexible printed connector, FPC connector, just like, you know, any of the other zillions of ones. I am missing something. Why separate the functions? Well, I mean, you know, we didn't design this, but I think it makes a lot of sense that fingerprint sensor itself is a chip. I mean, these guys, Apple doesn't say, hey, let's put a design team together and let's come up with a way to make a silicon chip that can detect fingerprints. Yeah, we'll spend like 40 years doing that, and then we'll be able to apply it to a phone. No, they go down to who knows a lot about fingerprint sensors? You guys do. Hey, can we buy you and all of your chips, and then we're going to use that chip in our application for fingerprint sensor. And then the same thing, like, hey, it'd be cool if you could touch the home button and it would sense whether you're touching it light or hard or across or down. And, you know, it would be cool if the home button was like a little touch pad so that you could do more with it. Yeah, that'd be cool. So how can we make that happen? All right, well, we have to ditch the little, you know, on-off button, and we need a way to kind of sense capacitance of your finger. So who does that? You know, they don't go build that. They go, who does that? These guys do. We'll just take this chip off of the, you know, it's like going to the grocery store for chips. Capacitance sensor? Nope, that one's not going to work. Oh, this one's perfect. Okay, and then they take that, and now you have two really independent functions controlled by two chips made by two different companies. So they're going to kind of marry them together with circuitry that is going to plug in to the logic board. So it makes sense that they would be separate functions. All right, let's see. I don't think it has anything to do with anti-repair at this point, unless we find out what Ben was alluding to. If there is everything we know so far makes sense from how you would go about designing to solve these problems. All right, let's see. Okay, I think we're ready. Oh, here we got some feedback. So the Turtle IC sends data to Mason, not Mason. Mason is touch. That's different. Mesa, like, you know, like the third grade spelling word. The crow flies over the mesa. That, Mesa. So the Turtle IC sends data to Mesa, but Mesa also provides the ground reference to Turtle. Yes, that sounds reasonable. I like a reasonable way to interpret that. Is error 53? We're not talking about that. I hate Reddit. I wish I could send all those people to Jessa. What does that have to do with anything? Reddit. Mesa, here comes Chris Long. Mesa sends the data to Turtle, then to CPU. I don't know about that. Mesa has ground reference for capacitive touch of the home button. Yes. Okay, that makes sense. Mesa sends its fingerprint sensor data. Okay, fine. Why do you torture yourself on their, Reddit? I downvoted my thread, says Lewis. That's really funny. So Lewis, hey, look, it's my friend Ben. Say hi. I know that you guys are super BFFs.
He loves me.
Yes.
I love him.
You guys are so in love.
Yeah.
All right, let's see if there's anything else on this. Does anybody else have any other questions? All right, let's go ahead and do our experiment. All All right, so here's our experiment. So just to recap for anybody that missed the lecture portion of anatomy and physiology for iPhone 7 home button, here's the recap. This is what we know so far. We know that there are 2 chips, Mesa, fingerprint sensor, and Turtle, home button data chip. So those 2 guys. And as it is now, what we're interested in is, can we make home button chip work independent of the Mesa fingerprint chip? So as it is now, the 2 are kind of they're married together, because it makes sense that the fingerprint sensor would have to have a way to turn the home button off in order for it to send data. So if you're pressing your fingerprint, it needs to say, hey, this isn't the home button click, you shut up. I'm telling fingerprint sensor data. So our proposal is, and then what Ben figured out, is that if you replace the button with a non-native one, so one from some other phone, you replace that, Mesa seems to pull the home button lines low all the time. So Mesa is not active because it doesn't have the right ID, so it's turning off the turtle chip, the home button chip, all the time. So the theory is, what if we took some home button and we severed the connection so that Mesa, we're giving up on Mesa. Mesa's fucked to begin with because Mesa's not original. It doesn't have the right ID, so fuck Mesa. What if we cut the interface between Mesa and the home button chip so that Mesa couldn't say, hey, shut up? So if Mesa's gone, then the home button chip itself may be able to signal when you touch the button if Mesa is no longer in the picture. Ben tried that already, and what he learned in experiment number 1 is that if you just simply cut it off, you're missing a ground. You're missing a ground reference. So what we're going to do now is we're going to try to cut off Mesa, and then we're going to try to rebuild that ground reference, and then we're going to try it. So that's our goal here. So is Larry still around, and has he got one to try? Because I'm not sure that this candidate one here is really a good candidate. Does anybody know?
Larry is here.
Okay, so Larry, what's up with you? What's up with your iPhone 7 here? What's the current status? Ooh. So my iPhone 7 screen just got fucked. Let's see. Where is Larry? I don't see. How come I don't see Larry on this thing? Oh, there he is. Larry is watching porn.
We can't hear Larry. I think Larry's mic might be muted.
Yeah. Are you saying words, Larry? Because we have no idea. Larry, your mic is dead. All right, I'm looking for, let's see. An iPhone 7 screen. iPhone 7. Hey, we hear you. Tell us about your phone. iPhone.
Ooh.
Larry,
hear me?
A little bit. Tell us about your phone. You want to do some work here? You want to fuck with this shit?
You'll see.
Larry's I2C mic lines are being held low. Says Ben Nash. Larry's internet blows. Indeed.
Yes, it does.
Yes, it does. Oh, there you go. All right. So what I'm doing right this second on mine is I'm going to take the original home button off, which I've never done before. I've not messed with this home button at all. So what I'm doing on mine is just taking the home button off, and I'm actually going to move it over to a test screen, and I just want to confirm that it's going to work on, or that it's the same on this test screen, because I just fucked the connector on this iPhone 7 screen that I had. So that's what I'm doing. I'm messing around here with this stuff. Okay. So Larry, what's up with your iPhone 7? Larry's gonna have to move to Rochester, New York, sounds like. I want to know what it was like when Larry was in New York City.
Larry needs to go to Mark Safer's house or Trent Innocent or someone who's got the 1 gigabit internet.
Yeah, seriously. Yeah, he does. Okay. So on mine, just to take a quick look. So this is my iPhone 7 screen that I just tore this flex, so it's missing the flex down there. So I want to make sure that wasn't, why this thing was not working. So what I'm doing right now is I'm just going to transfer. I have a new iPhone 7 screen, so I'm just moving the home button over, and I'm gonna test it the way it is. So maybe my entire blanking line thing was just, oh yeah, Justin, you like jacked the fucking cable like way back when.
It's very possible.
It's very possible. Now that happened, I had no idea they were so like fragile. Here, I'm gonna put you guys down here. Let me like this whole thing.
That blanking line, according to the schematics, is actually a clock line coming from the CPU. So I'm not sure where the word blanking comes from. But I'm not entirely sure how shorting it to round killed your home button function.
Yeah, maybe because I ripped the cable. And the whole time I'm like, ripping the cable is impossible. I didn't do any of this. Like, I didn't do any moving. I didn't move the button or anything. Like, this is a brand new phone. They're ripping a cable. That's not happening. All right, let's see how I can not rip this cable. I really actually don't want to rip that cable. All right, so that's coming off. All right, so let's go ahead and look at mine under the microscope as I'm going here. So this is the native home button that maybe works great. And there's our buddy Turtle. And then here's the thin flex that we're going to leave alone. And then under there is the thick flex that goes to Mesa. And Mesa's in there. And we are going to try to cut this. Now, what is our plan, just while it's kind of here natively? How are we going to build back this ground line? Where am I going here?
Okay, so...
Do we want to look back at your picture? Or no?
Yeah.
Or you got it memorized?
I haven't memorized, but I figure it's probably easier to show you. See if we can do that.
I want to know how many people can't understand the difference between Tennessee and Australia. The Australian connection is fantastic. The one from good old Tennessee.
I could be wrong, but I think Larry's using his phone.
Well, his phone's in Tennessee as well.
Yeah.
I think he's using his phone because that was the better one. That was the better option.
Yeah.
What I think. Alright, so I'm trying to be super gentle and not fuck my home button. Alright, so I'm going to have to lift up this chip?
No.
Oh,
no,
good.
so what I did was I traced out.
Yeah,
I traced out where that pad goes to. It goes to that little capacitor there. So you should be able to remove the conformal coating or the hot glue from above that capacitor.
Let's see. So where am I going? So there's 3 in a row here. Is it the side with the 3 in a row or the side with the 2?
It is the side with the 3 in a row, and it is the only
cap
in there.
Huh?
Yeah. Yeah, it's the capacitor that's there.
So the only cap, and then what side am I going into? The side close to the chip, or the side far away?
Yeah, no, the side close to the IC.
Okay, so I'm going from there to like just the home button ground plate?
Yeah, or potentially that little
the metal
ring
thing?
Yeah, that little ring terminal that the screw goes through.
Okay. All right. Totally doable. What do you think is going to happen?
I think that we're going to start getting data coming out of the IC, and I have absolutely no idea whether or not that data is going to be interpreted as anything by the CPU or if it's just going to ignore it.
All right. Well, let's say that this home button was I'm going to put heat on it. Let's say that this home button was not working because the cable was torn or something lame like that. In that case, how am I going to break? What's the best way for me to break the original button function? Because I'm going to need to break Mesa or whatever. Like, I'm going to need, I don't know, I guess just cutting it. That's going to be pretty brutal.
It's going to be pretty adamant about Touch ID not working.
I wonder if there's something gentler that we should do first by, like, pulling some line down or something just to kind of disable so that we know if we could, like, bring it back or something. You know, like, cutting it is going to be...
Yeah, I was really hoping that there was going to be a couple of filters on those lines in between the secret Mesa IC and the AD7149, and it turns out there's not. I know Mark Schaefer asked the same question earlier today. He said, is there a less destructive and sort of better solution for interrupting that signal? And it doesn't seem there is. So
what about the path of power? You know, can't we just figure out which is the 3V0 Mesa line going, you know, like a trace that, you know, I mean, we can get to all these traces. We could cut one, you know, like, the power one would be thick. Like, we can't just kind of sever that path to Mesa.
Well, we could, and the power is actually on the other side of the flex, the underside of it, the 3V Mesa. But we don't know what state that's going to leave the lines in. So we really want the lines not to be attached at Mesa at all. It may turn out that when Mesa is not on, those lines get pulled low.
Yeah.
Which is likely to be the case. So I don't think removing the
Do you think, is this the only data lines that Mesa it has? The only thing going on is the I2C turtle.
As far as the home button's concerned, it is. As far as the Mesa...
Yeah, like, just to... Like, is there another way that I could just disrupt the signal that... like, to kind of make it so that the board doesn't recognize Mesa? Like, is there another line that it's signaling on, or is pretty much all of its data coming through those two lines?
Well, see, Mesa itself has its own data lines, so it's got its own I2C and its own SPI lines. So the only sort of interaction that Mesa has with the turtle I2C lines are that it can pull them down and disable that communication. So I mean, we could potentially sever the Mesa specific I2C lines or the Mesa specific SPI lines, but whether or not that still leaves the turtle lines stuck in a low state, I'm not sure.
Okay. And now this little thing that you used to figure out, did you use a multimeter to figure this out, that, you know, these I2C lines are in a low state, or did you use a magic tool? I
had a logic analyzer, and it did not work.
Is that different than this, like, USB thing that Jason made me buy that I never used?
I think it's probably identical. I don't know. Does that look like yours?
I don't think so. I don't even know where that is. Oh wait, it's like near me, because I think that it is this is what this is. What's this? What the hell is this? Can you see this?
I can't yet because the stream is delayed.
Oh, okay. Well, in a few minutes. What the hell is that? I'll say it soon,
yeah. I think there's about 10 seconds delay or something on it.
Okay, so there's that. So coming up soon.
That's a DCSC or something cable. That is for communicating with the serial interface via Lightning.
Yeah, that's what it's for. That's what I remember. I can't make it be different. Yeah. I can't solder some wires on some shit.
Not particularly, no.
Alrighty.
It has a very good use, but not here.
Okay. Why did I get that? I don't even remember that. That was like back when Jason was here.
I think you got that because when an iPhone is booting.
Huh?
No, I think it was more in relation to boot loops. So when an iPhone's booting, if you can access the developer or the debug serial port that TriStar has access to, you can view serial data when the phone's booting. So it tells you things like
right, yeah, I can read it now.
Tells you the serial
all
number.
Coming back to me now.
Yeah, so if you have a kernel panic, or if you have a boot loop or something like that, it may shed some light to why.
Yes.
So one of the things that it does is during boot up, it tells you whether or not there is a gas gauge signal.
Yes. So this was like error 27 and blue screen of death days.
Yeah. So its main sort of use out in the field, I guess, its main the main place that you will see it pop up is with NAND programmers. So the NAND programmers, or upgrading memory or writing serial numbers, etc., tend to use that serial interface. And a special programmer has an iPhone port in it that is running development iBoot.
Mm-hmm.
Yeah. So.
All right.
But you have the all-in-one NAND programmer, so you don't need that cable for that.
All right, so this is this connector doesn't seem right. Let me look at the old one. What is going on here? No, that's all right. All right, so I'm just trying to connect my original home button without, I'm trying to just be really cautious and not make it so that we can't learn anything because any kind of little damage to this. So I'm really trying to just be cautious and not have any problems.
You guys hear me?
Yeah, we can hear you. What's up with your iPhone 7?
I've got the jumper ran here, and no, we still don't have a home button function.
So what was the original deal? Tell me about this phone.
It was just the iCloud Lock 7.
And it had, did it have home button function?
Yeah, it was fully functional. Interesting, whenever you hit the power button, you get a little flash on the screen, and then you have to do a battery pull in order to get the phone to power back on again.
That's weird. So this is an iCloud locked iPhone 7 with home button function. And so therefore we're concluding that it must be the original home button because that's what we know about these things.
Yeah, the home button was working. It was functional before I worked on it here anyway.
And then you just cut the big flex, severing the connection between Mesa and Turtle. And then you soldered the wire from the cap, on the edge closest to Turtle, to the ring thing.
Yeah, to the ring on the back of the home button, yes.
Mm-hmm. And you turned it on, and
nothing.
Nothing. All right. Well,
I'm booting back. I'm booting back up here, so we'll see what happens. Whatever.
All right. How about restore?
I have not restored it yet.
Everybody goes, now I can hear he's not Australian. That's pretty funny. All right, so let's see. Oh, here's my phone. So my phone booted back up, and it has, I don't know if I originally had that or not. All right, here's the, hey, look at that. My home button works great because I didn't do anything other than a screen swap. So my blanking enable was just a tour of fucking flex.
Yep.
All right, so now I have a working home button. I got
so do you want to still cut it up?
Well, sure. That's what it's here for. I mean, I want to think for a second. about whether or not we should. Let's look back at the schematic. Let's look back at the schematic all together. So you already probed all these things around the connector, yes?
Yes.
So you know what's what. Take us back to your view of the schematic.
Okay, I just need to swap mice.
Swap wires.
Swap mice.
Oh,
I
mice.
have two computers going with one keyboard and mouse.
I see.
So what do we want? We want the iPhone 7 schematic or the AD714?
Yeah, the 7.
Yeah.
Is that the 7? Yeah, that's like way too fucking small for me to see. All right, let's see. Okay, so you know what all those do? Tell me what's up with all the Mambas. Touch, force touch?
Yeah, so all of the Mamba or Mamba is
Oh, is it Mamba? Is it Mamba in Australia?
I've got no idea.
Wait, have you ever, when was the last time you did the cha-cha, Ben? Or the tango?
I mean, I have to say never.
What? Oh my God.
So. I mean, if I did, it would have been in like, I don't know, primary school camp or something.
Camp. Okay.
Yeah. Yeah, you know, when they force everybody, they get all boys and the girls on one side of a room, which they're probably not allowed to do anymore because, you know, that's segregating sectors.
That's right. That's not PC anymore. We used to have the circle dance where it would be like girls on the inside and boys on the outside, and the circles would walk around each other. Then they would blow a whistle, and then you were just supposed to turn around and dance with whoever was in front of you. That was their sort of way to be inclusive and make everything fair. Yeah. Well, the Mamba is a dance like foxtrot, not really like foxtrot. So I think that's what that means. Mamba dance. I don't know. All right. So, is there any other line on there that has anything to do with Mesa? I really can't see it. It's way too small. There's Mesa power. What about the 1V8 Mesa? What's up with that?
It's another power rail. For the Turtle I see it seems to be an enable line, so it just turns on.
All right. So what should we do here? We could cut this flex right now, but is there anything that's a little bit more subtle that we could do?
That is a great question. Not that I've discovered.
Okay.
But we are live streaming with a whole heap of really knowledgeable people, so maybe somebody in chat will come up with.
Yeah, so let's see. If we kind of stare at this, if there's anything. So what we have now is an iPhone 7 working with its actual native paired button. What I'd like to do, somebody told me they were going to send me an iPhone 7 just iCloud locked iPhone 7 button. So I'm gonna look around. I'm gonna ask my team real quick if they did that, because if they did, then we could just kind of hang on to this button, plug in that one, and do this experiment with that. Can we full screen Ben Duffy? Yeah, we can. I'm gonna go look for that. So I'm gonna make this. Let's move that. Let's make this big. And you can read chat and respond to that. And I'm gonna just have to ask my team. I'm gonna see if I can see if that might be here. That'd be cool if it is. So they can still hear you.
Everyone can hear me. I have control of your stream. That's dangerous.
Oh, pretty much everybody has control of my stream. It's going around.
I found that.
Where is the man?
So Chris Long did have a suggestion, which is probably more intelligent, which is to scrape away the coating on the Touch ID cable and just cut the I2C lines.
Oh wait, Wyman just sent me some messages. Let's see what he said. Wait, was that from today? I think he sent me the same pictures. Oh wait, let's see, what's this? Oh, I think it's him. Damn, he already knows this. I think, have you seen this? I don't know how to send. I'm going to send you to this in knitting group.
Okay.
Hold on a minute. It's pretty much the same thing you just did. The mapping out of these lines and where they go. I want to know where. I really just want to learn how to speak Chinese. That's what I want. Let's see. Let's see. All right. So do you already have you already seen that?
Not that exact one, but yeah, there is a similar one. And I'll see if I can send it to you, which did help me in my adventures. Where are we? No, that is not the right button.
All right. There's the other two. All right, I'm gonna try to look for this 7 home button. So Larry, did anything work?
Larry is gone. Now, see, here's what I would like to know. That image that you just sent me.
Yep.
It references the capacitors and the resistors as specific components, like as if whoever made that image has got schematics for the actual flex.
Right.
Where are they? I want them.
They're inside a purple, a red, or a blue dongle that you need to speak Chinese in order to access. That's what I think.
Right. Cool. That wouldn't surprise me.
Who should we nominate to learn Chinese? That's what we need.
I mean, I know that Jim Roberts already speaks quite a bit of Chinese, so
What?
yeah. So maybe we just need to commentate.
Or does he speak Chinese like it's written on the back of packages and stuff?
Well, no, he speaks to people in Chinese. I think only in text. I don't think. I'm not sure. I'd have to ask him about that.
Well, I'm super excited to go to China, that's for sure.
Yeah. Well, see, I think that's the best way to learn Chinese is to just jump in the deep and go to China and
Yeah. Yeah.
Yeah, guys, I didn't get nothing to work.
So do you think I should maybe not cut this flex? I don't know. It's a good experiment. I think.
So the question is now, Larry, do you have access to an oscilloscope?
I do not.
Damn.
God damn
Because
it.
because what we want to know is data coming out on those lines, and if it is, then we can confirm that the software is ignoring the data.
Right.
I may be able to find some contacts that have one, but I do not have one here.
Yeah, see if you can chase one up, because that is the unknown at the moment, whether or not it's also software. Like,
Gotcha, I understand.
All right, let's look at this. Let me see what I want to do here. I don't know. I would really like... Whoa, why is Mandy asking me if I'm going to come to China? How many people are watching this stream?
There was 185 a moment ago. Now there's 177.
Yeah, because we're not doing anything. Got it. All right. So what should I do here? What should I cut this Mesa off?
Well, Larry has, and
I know.
it has not.
So it's like that's why I'm kind of hesitant. I'd like to.
Yeah. So now we're sort of. I feel like you may get stuck in the same boat as Larry. And now we need an oscilloscope, which none of us have.
Well, I have an oscilloscope, but it is located in New York, in Brooklyn, New York right now. Let's drive down.
Yeah.
Lewis has got one. Let's just go take his.
Yeah. Well, just transfer your stream to the phone, jump in the car, and off you go.
Yeah, it'll be fine. We'll just chat. We'll just rant on stem cells and Doritos for a couple of hours.
Yeah,
that
sounds good. Mercury and vaccines and.
Mm-hmm. So from this picture, it's like I kind of want to like just sever traces, but I guess it's not going to work.
That's what Chris Long suggested. That's probably a bit of a less invasive way. Then you've only got to repair 2 traces.
Right.
Yeah.
So I'm looking at that picture, and
let's go to that. Can you pull that up?
Let's see if I can. All right. Let me see if I can find that. Oh look, I got one. I'm not far from Geelong.
I just saw that.
Yeah. All right. Great. Well, Google, send a message to GeelongMicrosoldering.com. Get in your car and go over there because Ben. Let's see. Could you knock off a pin? A pin isn't really going to help us. All right. Let's see where. Let's see if I can find this picture. See. All right, let's go back to this. Let's see what happens. I'm going to add an image if it'll let me do this. So let's do plus image, create a new image. Okay. Image file. Let's see, I need to save it, I think. Downloading. These are the kind of streams that get super boring, so we need to do something one way or the other. All right, let's go.
Somebody offered earlier to pay you an amount to have you jump up and down on the spot. So
jump up and down on the spot.
Yeah. So I mean,
well, I got to get my bunny suit in and my wet T-shirt and get going on Twitch. That's gonna be great. Yeah, I can't wait to just start raking in the dollars. It's gonna be awesome.
Yeah.
Let's see. Where is that picture? A guy in Melbourne has a scope. Can't believe it. It's like I almost never use the oscilloscope, and so I sent it to Jason to be able, Jason Kobler, to be able to do a story on piece of shit chargers, and that was a while ago, like a serious long while ago. And you know, and it's one of those things where it's just like, you know, I don't need this back anytime soon. Well, now I do. Now I do.
You never need it until you do.
That's right.
It's a bit like things are always working until they're not. When somebody brings in a water damaged phone and they say, you know, Everything was working until it stopped turning on.
Until today.
Cool. That's relevant. So everything was working until it didn't work anymore.
Yeah.
It should be easy then.
That's right. All right, I got this picture. All right, so now we're all looking at this picture. I think so. You know, is it these two? These right here. This is the path out of Turtle that's going to Mesa. Do you think that there's a different return path? That if you cut off Mesa entirely, that you've cut off, you know, it's going in and then it's coming back out. Same name, going in, coming back out, and you know, how does it get from there to the connector? Let's see if there's a other picture that had that flip side. So here's the back side. So now I got to do the same thing and download that. Download. Open. Save as. Button back.
So somebody called Brittany Paul had a suggestion, which is that if the Mesa chip can be disabled by an enable line, so perhaps by removing a filter on the enable line,
like the 1v8,
without pulling down Turtle, and the answer to that is we have no idea because we don't have a scope. So it's very possible that that's the case, but we don't know what state that will leave those lines in without a scope.
All right, let's see if I do another image. So let's do image. Create new. Okay, find it. Browse. Button back. Hit OK. All right, so now we're looking at the other side. So let's kind of really look at this and kind of say, do the turtle lines, I won't be able to see this because I'm projecting and it's really far away. Do the turtle lines leave or do the I2C lines leave Turtle, go into Mesa, and then do they come back out? Like kind of making a round trip?
I don't believe so. I believe that the I2C lines that come out of Mesa specific to Mesa. If they
I liked you better when you said I2C. I'll have to tell you.
I think that if that were the case, there would be no need for multiple I2C lines.
Oh, look at you. All right. Okay, so what time is it? So it's pretty late. I'm not sure that it is a great idea to just cut the flex. So the thing that we have been that was the intention to sort of execute today was to go with the laboratory exercise of saying what happens, and I'll show you guys this just to be crystal clear, based on what we talked about. And I think, Ben, you did a great job explaining all of this theory. But the idea is that if we were to cut off Mesa, just cut it, sever it, and we know that then Turtle no longer has a path to ground. So we were going to make a jumper from right here, that spot there, this cap, to this ring ground that gets screwed in there. So make a path to ground. And then see whether or not the output I2C data lines that leave Turtle and in theory go into the connector and to the CPU, if those would no longer be pulled low by the fact that Mesa is cut off. So Mesa pulls those lines low when you have a non-original, non-native home button. When you do have the native home button, when it's the right Mesa, then those lines that leave Turtle and come through the connector have data on them, ones and zeros. So it's hard for us to see ones and zeros with a multimeter. We could try, but it's hard for us to see that change in voltage, those ones and zeros, to measure that kind of neural activity. We need an EKG machine, which is an oscilloscope. My oscilloscope is on loan to somebody else right now, so I don't have it here today, and I'm about to go on a trip for a week. So that's why I wanted to do this tonight, regardless of result. So what our hope is that if we were to just cut off Mesa and say, we're going to cut you off so that you don't have the ability to pull the I2C lines with the home button information low, and that they should be able to leave and carry their data through the connector to the CPU. However, our buddy Larry, who's also on the stream, Larry tried it. So we don't have any video on him. It's got some, he's dealing with the piece of shit internet over there in Tennessee. But what Larry did on team investigation, he cut off Mesa, and then he made the jumper from here to ground to investigate that idea. And what he found was that there was no home button function. However, he would get a flicker, some sort of a flicker when he pushed the home button. Chris Long, if they cut it, I'll rage. Oh, I like that idea. I want to make somebody rage. Don't do it, because before I mess up one, that ground is broken. All right, so let's see. Did anybody else try this? I'm gonna read chat for a while. So right now, we're kind of left with not having the right tools to be able to really ask that question. So I'm not, I don't think there's anything that's really instructive that we can do until we get back to the oscilloscope. I think we should get back to the oscilloscope.
You guys have got functional home buttons and or at least you do, Jessa, have functional home buttons and no oscilloscope. I have access to an oscilloscope. If I head down to the place that I got the iPhone for testing from, which is iPhone Repairs Geelong, just down the road, I can use their oscilloscope, but I fried the AD7149 that I had.
Right. And I've got an extra 7149 right here. I could get that off and mail it to you.
I've already ordered one.
Yeah. So there's that. Yeah. That's when the beauty and the of the internet and everybody being all connected kind of sucks when you're really not neighbors after all. Yeah. All right. So I think this was great for kind of theory, but this is going to end up being kind of like we have to put these together in a series called the investigation of the iPhone 7 home button. But I think I'm glad we did this tonight anyway. I like the format of doing these hangouts with folks. But I think that we need to have the right tools. So before I really fuck up this home button, I think we could use it to do some comparisons, especially because I'd like to use this phone and really compare a non-functional home button with a functional home button and see what's going on before destroying this. Especially because Larry just did it and did not, and it didn't seem to work. And Correct. If your chip is actually not fried, you're concluding you did it as well and it didn't work, and your conclusion is that you fried the chip. Maybe you didn't fry the chip.
I know I fried the chip because I put it back on a non-working flex and it did not work. But the Touch ID does, so.
Oh, okay. All right.
Yeah.
Well, where's the AD chip from, or the turtle chip from that flex?
It was broken. So
Okay.
it was physically damaged.
The cat's eating it. All right. So what we're gonna do, I think we're gonna just put a stop here because it's late and I need to get packed and get the fuck out of here. And I think that we're going to get the right tools. So I'm gonna call back my oscilloscope. Maybe that'll be here when I get back from Walt Disney World, and I'm gonna dig up a one of these eBay home buttons that don't have a Mesa to begin with. I want to try that, and we can also dig up kind of that combination of working and non-working and ones that don't have Mesa, and then just kind of continue on. Let me read chat for a little bit, and then we'll click off. I haven't read chat here for a while. Let's see. I see.
I'm sure we've
comments. What?
I said I'm sure that we've missed a lot.
Okay. All right. So people are talking about multimeter using it. Can't see your cursor, says Jason. Let's see. Hello, Jessa. Could you heat up Mesa and just remove it from the metal plate? Nope. I mean, we have done a lot of dissection of Mesa, and it is, this is what Mesa looks like. This thing, you can't heat that thing up, and it's already not on the metal plate. I mean, you cannot do anything with an intact Mesa. You might as well just cut it off. There's not any separating of that. That's wire bonded on there. But that's a good thought. I like seeing. Try to short the two caps on the bottom. Why and what? That's that's unclear. So if you want to make a suggestion, you have to say short the two caps on the bottom, which are on line XYZ, and then that would, in theory, blah blah blah. Like, spell it out. All right. So people are talking about oscilloscopes. Yeah, we got that basic one as well. Rigol, whatever it is. Metastatic I2C tumors. The genetics was fantastic, says Paul Daniels. All right. Lewis is number 5 on the front page of Reddit. Wow. He was wondering about what he did to make the algorithm god smile on him. He's funny. So is removing the iPhone 7 button and placing it on a new replacement screen breaks it? Nope. That's one thing I did that works. No, you can do it. You can transfer it, but you can't tear it, damage it, fuck it up, or break it in any way, or else you will lose home button and fingerprint sensor function. Let's see. Cut one line at a time. Yeah, I think I kind of like to cut one line at a time as well. I messed up that secondary flex before, but click still worked. All right, you messed. Okay, let's pay attention to that. So Ben, we have a guy who's saying that he messed up that secondary flex before, but click still worked. I think secondary flex. So you got to tell us what you mean by that.
Yeah.
The little flex or the big flex? Let's take a look under the microscope. So this guy's saying, I messed up where did you mess up? Here, tell us. Did you mess up this? Because I find that hard to imagine. Did you tear this? Did you tear it a little bit or all the way through? Or did you tear this, the big one, this one? Did you tear Mesa Flex? Or let's say, did you tear Turtle Flex? Or did you tear right here, like this one's torn? Did you tear by the connector? Where exactly did you tear? Tell us. Show us a picture so that we can let's see. Stick your multimeter leads in your USB port so you can use continuity over the internet. That's a great idea. All right.
Yes, Ben is full of them.
Yes, so Paul Daniels is asking, are you Geelong Microsoldering? Yes, he is. And Paul Daniels says, I've sent a few people there for TriStar replacements. And I'm sure he did a fantastic job. Let's see.
With the current state of the queue, I am pretty sure that I took weeks to do it. Sorry.
Weeks? Well, you guys should get together. I asked him the other day on some other stream how far away he was from you. He said something like 2,500 kilometers. So it didn't seem very close.
No.
That sounds really seriously far.
I think that's about the distance that Ben Natch to me.
Yeah, you guys have a giant continent. Your state is a giant continent. That's funny. This guy goes, I fell asleep watching Lewis and woke up here. That's really funny. What if you removed Turtle? Okay. I'm looking for anything relevant to this problem. Okay, so I think that it's later than I wanted to be here. I wanted to just kind of come in and do this experiment really quickly. And I think that this really deserves more thought. It's super fun. I really like this format. So I think it's great to hear what Ben has to say in person and interact with live stream folks. So, and thanks to Larry for going out and kind of getting this experiment done. And I'm glad that Larry got that done on the iCloud lock board, especially because this one is a working home button. So
yeah, you don't necessarily want to kill that.
I mean, I don't mind killing it. It's for research, you know. It's here for science. But you know, I think it just deserves some more time. Get an oscilloscope, get a couple of new buttons, and see if we can continue thinking about this. And maybe you have a logic analyzer, right?
I do.
Of some sort. All right.
Yeah.
Well, we will pick this up. So we'll call this video 2 in the series of iPhone 7 home button reverse engineering, and we're going to continue to beat on it and see if we can at least figure out what's going on and see if we can come up with either a solution or at least an understanding of why it is the way it is and what we can do about it and what we can't. All right, so thank you very much to Ben Duffy from Geelong Microsoldering in Australia and to Larry Johnson from Handheld Rehab in Tennessee. So both of these guys are absolutely fantastic folks to send in for your mail and repair, and they are incredibly thoughtful, smart guys that stare down microscopes all day, every day, just like me. And there's a lot of other folks that I really respect in the community, and I think it'd be great to have more folks on the channel and be a repair family. All right, so I'm gonna hang up and see you guys in episode 3 of Home Button Drama. Right,
Fantastic.
so
See
I'm
you
gonna
later.
I'm going to hit end stream on this.